Thanks for coming back. We're doing lesson 9.2 today, and we're actually going to do some calculus with trig functions. Today we'll focus on differentiating the trig functions, and guess what we'll do tomorrow? You got it, integrating them. But today, once again, it's differentiation. So I give you the graph of sine x, and I hope you remember that graph from pre-calc 12. What I'd like you to do today is, because when we're talking about differentiation, we're talking about the slopes of tangent lines. So I'd like you to estimate the slopes for the tangent lines at various points on this sine x graph. Specifically at negative 2 pi, at negative 3 pi over 2, at negative pi, at negative pi over 2, at 0, at pi over 2, at pi, at 3 pi over 2, and finally at 2 pi. Okay? And I'd like you to, after doing your estimates, plot these slopes on the plane below. So that negative 2 pi line in red, that looks like it's a positive slope. I'm just going to assume it's like positive 1. And that blue line there, that must be 0. Yeah. And that black line there, that's a negative slope. So maybe down here somewhere. And if you do this, what you see, hopefully, are these lovely points. And don't forget, you don't want to connect them with lines, because these are curves. Hopefully you'll see something like this. Look familiar, friends? I hope so, because that's just cosine of x. So, this gives rise to the derivative of our first trig function. So the derivative of sine x is just cosine x. Okay? And once you get underneath is where I replace x with u. That's like another function. So there's cosine of u with u prime. It's really the chain rule version. Okay. Now, if you do the same thing with cosine, you will actually get the graph of negative sine x. So once again, I changed it to u. Then of course you get an extra factor of u prime. Now, this tangent one, I'm going to ask us to try to prove over here. And I can do that by now quickly saying that tangent of x is equal to sine x over cosine x. So if I wanted to take the derivative of tangent, I just have to take the derivative of sine over cos. Well, what's the derivative of sine over cos? That's a fraction or a quotient. Yes, the quotient rule I need to know. That's right, low d of high, the derivative of high is cos x, right? That's the derivative of sine is cos. Low d high less high, which is sine x. D low, the derivative of cosine is negative sine x. Draw a line and then below, put the square of the low. And so what you have here is really just cosine squared x plus sine squared x all over cosine squared x, and the numerator simplifies to Pythagorean identity. Yeah, 1. And 1 over cos is just secant, so this is just secant squared x. And there's your proof of number 3. Once again, you need to memorize all these. I won't prove cotangent and the other ones, but they're pretty much done the same way. But yes, everything I put in the box here, you better know and memorize. Okay. So, knowing that, and you've memorized that, let's go ahead and try to find some derivatives. So ddx, of course, stands for the verb, the derivative with respect to x of cosine of 3x squared. So the derivative of cos, we know is, yes, negative sine. So negative sine of the function 3x squared. And because this is a function with a function, we need to add on that hook-on value, or the u prime. So in this case, the derivative of 3x squared is 6x. And if you want to write this nicer, then most of the time math people will put the 6x in front. So negative 6x times sine of 3x squared. Done. Number 2. Remember that tan to the power of 4 5x is really this. It's tangent of 5x, all raised to the power of 4. So knowing that, if I take the derivative, we're going to work from outside and inside. 4 gets brought down because the tangent 5x is my function, raised to the power of 3. And then now I have to take the derivative of the inside, which is the derivative of the tangent 5x function. The derivative of tangent is secant squared of the function, which is 5x. And notice here I still have another function within a function, so an extra factor of 5. And if you want to simplify, 4 times 5 is just 20. So 20 tangent cube root of 5x times secant squared of 5x. And that is the derivative for number 2. Numéro 3, cosecant. Ooh, that's number 6 over here. So the derivative of cosecant is negative cosecant of the function times cotangent of that function. That's from number 6, by the way. And then, because we have a function within the function, we have to use chain rule. And the derivative of t over 2 is just an extra factor of a half. And if I want to write it nicer, I'll say negative 1/2. Sorry, this is not cosine, it's cosecant. Sorry. Getting tired here, Mr. Lee. Cosecant t over 2 times cotangent t over 2. And finally, number 4, we have e to the negative 2x times cotangent x. Hey, hey, hey. Did you hear me say e to the negative 2x times cotangent x? Product rule. A prime. So a prime. E to the negative 2x's derivative is e to the negative 2x, but it's not x, it's negative 2x, so chain rule again. There's my a prime b plus b prime. What's cotangent? Oh yeah, that's negative cosecant squared x. B prime a. And if you wanted me to write this a little bit nicer, negative 2 e to the negative 2x cotangent x minus e to the negative 2x cosecant square x. And if you want to do some factoring, maybe I can factor out the negative e to the negative 2x. And that leaves us with 2 cotangent x plus cosecant squared x. And that's all you can do. Okay? Alright. Turn the page. Because got a few more examples to try today. Hey, can you do this? Without a calculator, find the slope of the graph of y equals 3 cos negative x, where x is these two values. Finding the slope, of course, means finding the derivative, so let's calculate the derivative first. The 3 is a constant, let's ignore it. The derivative of cos is negative sine, so it's negative sine of negative x. And then because you have a negative x, the derivative of negative x is negative 1. So this just becomes positive 3 sine of negative x. Evaluating this at pi over 2 means I want 3 times negative sine pi over 2. Sine negative pi over 2, that is what value? You should have memorized these. Negative pi over 2 is in, actually it's right on the y-axis. Sine is the y value, so I believe it's negative 1. So the answer here is just negative 3. And similarly for part B, I can just use the same derivative. and plug in the value of negative pi over 3. So negative is positive. Sine pi over 3 you should remember as root 3 over 2. So this is just 3 times root 3 over 2. Or how about 3 root 3 over 2? And that's the slope value at x equals to negative pi over 3. Okay? We'll ignore example 6 for now, because I didn't actually teach you unit 8 yet. And so once I do unit 8, actually lesson 8.4 for unit 8, you can come back and do this example. But for us right now, let's focus on example number 7, and making sure you can find the relative extrema for these functions. So once again, I've just taught you the skill of derivatives. You can now apply this to any type of question, whether it be a max-min problem, which is what we're doing here, whether it be a curve sketching problem, whether it be finding the approximation of a tangent line, whether it be related rates, anything that now involves trig as a derivative application, you can do. So how do we find relative extrema again? Yes, take the derivative. So taking the derivative of sine, that's cosine. Taking the derivative of cosine is negative sine. So you actually have here cosine x plus sine x. So we found the derivative. Now what? Relative extrema, of course, is when the derivative equals to 0. So you want to now set f prime of x equal to 0. So you're really solving cos x plus sine x equal to 0. And I'll actually separate these two trig functions, and you still might be, this is tough to solve. Yeah. I forgot the negative 2, right? But I guess what you could have done now is you need to change this into one trig function. And to do that, I would suggest dividing both sides by cos. Because sine over cos then gives us tangent. And now you have the equation tangent equal to negative 1. Hopefully you know how to solve this. This is inverse tangent of negative 1. Tangent, of course, can be found in quadrants. With their negative, that's quadrant 2. And also quadrant 4. It's negative 1, so the ratio here must be negative 1, 1, which must be root 2. And that means this angle must be 45 degrees, or pi over 4. Same thing here, right? Negative 1, 1, root 2, pi over 4. So how do we find the actual angle measure? In this case, that would be pi minus pi over 4, which is 3 pi over 4. And in the second case over here, this would be going 2 pi and then minusing pi over 4. 8 pi over 4 minus pi over 4. Once again, this is review of Math 12. 7 pi over 4. Whew! But if you think you're done, you're not. I guess we actually found the x values, but you didn't tell me which one's the max or min. So remember how we did that? Number line. In this case, I'm starting at 0, going to 2 pi. And now I have these values of 3 pi over 4 and also 7 pi over 4 that are my critical points. Once again, how can you figure out which one's a relative max or min? You look for the sign change, which means you have to find the signs for each of these regions. I'll let you just plug in values into the derivative, but I've already done it. This one's positive, this one's negative, this one is positive. So what's my conclusion now? Which one's a max and which one's a min? Yeah, 3 pi over 4 must be a max, and 7 pi over 4 must be the min. So we have here a relative max at the x value of 3 pi over 4, and the relative min at the x value of 7 pi over 4. So once again, all those applications, all the things we did before, now you can do them with trig.